Just so y'all know I'm recording this. All right, so I'm on module 7, page 1. The big thing that you guys are going to want to note, we're going to talk about, well, wait till I get to it. The first sentence on the page is highlighted. Grounding is the intentional connection of an electrical system to earth ground. Grounding is the intentional connection of an electrical system to earth ground. Up at the top right of page 110, overview of electrical system. The first 2 sentences are one highlight. The grounding system is a major part of any electrical system. It serves to hold all non-current carrying parts of the electrical system, including enclosures, at zero potential with respect to ground. Whenever I say zero potential, what I want y'all to think of? Potential difference. Voltage. So voltage, like a voltmeter, reads potential difference, right? So you have to have a zero. Like if I just put my meter in 120 and then I put it in another socket at 120, what's the difference of 120 and 120? Nothing. Zero potential difference. You have to have a baseline. And that's why you have to have a ground. You have to have a zero potential. Then you have to have like a plug would be 120. So your potential difference would be 120 volts. That's what meters read, is potential difference of voltage. So it's very important to have a ground, because if you don't have a zero to base stuff off of. The next sentence is an online test question. High voltages can accidentally enter an electrical system as a result of a lightning strike or result of lightning strikes. Lightning strikes. The breakdown of insulation in the supply transformer or chance contact between high voltage supply lines and their incoming service wires. So you're like the ground to your house is going to keep all that stuff from going inside your house. The grounding wire that runs out of your panel at your house is what provides a low impedance pad for a lightning strike or something like that to get to ground without damaging other stuff. 111 grounding system terminology. I'm going to give you all a couple of these that I've highlighted, but these would not be a bad idea to kind of wrap your head around the different ones because a lot of them sound the same. I've got bonding, the whole thing of bonding highlighted for a couple of different questions. Is the permanent joining of metallic parts to form an electrically conductive path that will ensure both electrical continuity and the capacity to safely conduct any current likely to be imposed on it. So bonding doesn't just mean connecting wires together. You can also, like if you have a metal raceway system, like we have on the walls here, metal conduit can be bonded together. Like we've talked about grounding lock nuts and stuff like that. But you can actually use metal conduit boxes as the ground as long as they are bonded all the way back to the source. Next one is the third bullet point I've got highlighted. Grounded is connected to earth or some conducting body that serves in the place of earth. So this is like the ground rod or grounding ring or grounding to your water pipe at your house. That's what grounded means. I don't have any more highlights on page 1, but it is good to know the grounded conductor. It's good to know that one. So your ground conductor, anybody know what that's another name for? It's your neutral. The grounded conductor is your neutral. So if you opened up the main panel at your house, your grounds and your neutrals are connected together. So your grounded conductor is that's your neutral. So those are ones. And then I don't know if it has it. Yeah, flip over to page 2. Page 2, I'll tell you whenever I have a highlight. The first one talks about is not highlighted, but the equipment grounding conductor, that's an important one. So that is literally the round part of a plug. That's what connects your ground of whatever equipment you're using to the grounding system. That's your equipment grounding conductor. So that's in your house or residential systems, that's your bare wire that runs with everything else. In commercial settings, the ground wire has to be insulated, so it's either tagged with green or green with the yellow stripe. I do have the neutral bus highlighted. Neutral bus, terminal connecting point, such as a terminal strip or bus bar and panel enclosure to which the main circuit and branch circuit grounded current carrying conductor terminates. So that is the bus bar or the bar with all the screws in it that connects all your neutrals or your ungrounded or your grounded conductors all together. Not highlighted, but right below that, ungrounded bus bars. So that's your phase bus bars. So those are your hot bus bars. In your house, you have two. You have two different phases of 120 entering your house that add together to be 240. Next highlight is in 120 grounding components and techniques. First sentence is highlighted. As implied by the General National Electric Code requirements outlined above, there are basically two types of grounding for electrical wiring: system grounding and equipment grounding. So system grounding would be like grounding panels. Equipment grounding would literally be grounding of your equipment. Yeah. Skip a sentence and the rest of the paragraph is a separate highlight. System grounding relates to the service entrance equipment and its interrelated and bonded components. That is, one system conductor is grounded to limit voltages due to lightning, line surges, or unintentional contact with higher voltage lines, and to stabilize the voltage to ground during normal operation. Basic system grounding. So they show, I don't have it on the board, but the figure 1 on page 3, like that's normally how like the transformers outside your house are set up. You'll either have 3 transformers or you'll have 1 transformer, just depending on the incoming voltage. And you can literally look and you can see all the different lines up on the transformer outside your house and how they're connected to the wires going below. But the ground, like you can see the Y to Y configuration all the way at the top. Like you can see the 2 grounds that are pulled off of those. Like that ground is literally the one that comes out of your box and goes in and connects to a ground rod or ring or your water pipe or something like that. Top right of the page, first full 2 sentences in the top right of page 3 are highlighted. The 4-wire Y to Y arrangement is the most common and is one of the distribution systems shown in figure 2. It typically produces 120 208 volts or 277 480 volts. So like whenever I say 120 208, like if you've done the motor trainer, if you measure the voltage on each leg, like each leg to ground is 120. But if you go in between phases, it's 208. Same thing for a 480 system. One leg to ground, one leg of 480 is 277. But if you go in between phases, it's 480. Skip 2 sentences, and I've got the delta. The delta, or the closed path arrangement, can provide 240 3-phase or 480 3-phase. The Y to Y, it said, is the most common. Delta to delta is common in like systems that aren't connected to a power grid. So systems that have like their own power source. The Navy actually uses the delta system quite a bit, because I think I've said this before, because they can drop a whole phase and still keep like the boats running and stuff like that. They're just running at a higher amperage. But it's like a separately derived system is the one that uses the delta to delta. Most of the stuff, everything I've ever seen is Y to Y connection. Like some motors might have a delta star or something like that, but like for the system itself, it is usually Y to Y system. Grounding electrode system 122. Second paragraph is highlighted. In general, all the following grounding electrodes, if available, and any made of rod, pipe, and plate electrodes must be bonded together to form the grounding electrode system. I have the first bullet point highlighted. An ungrounded water pipe in direct contact with the earth for no less than 10 feet. So you are allowed to use the water pipe of your house as a ground, but it has to be in direct contact with the earth for 10 feet, or at least 10 feet. The last bullet point on the page is highlighted. A ground ring encircling the building or structure in direct contact with the earth at a depth of not less than 2.5 feet. Below grade, this ring must consist of at least 20 feet of bare copper conductor that's not smaller than 2 gauge wire. Key in on a ground ring, like a ground ring has to be no smaller than 2 gauge. Key in on that 2 gauge for that highlight. Pages 4 and 5 just show the different connections. You can look through those if you want, but they just show the different, like inside, like the circles are literally the transformers, and the H is the high side, X is the load side, and you can just see how like a Y to Y, delta Y, and delta to delta configuration are set up. You can do those if you want, but no highlights on pages 4 and 5. Flipping over to 5 and 6, which I had. I don't have highlights on this page, but that figure 4 is an important picture. So you can see like like that'd be like the panel at your house. The green wires are your actual grounds. It's important to note that like everybody can see how all your grounds and your neutrals are all connected to one bus bar in the top right of that panel. That has to be at the main panel. A main panel is where you can connect all your grounds and neutrals together. But if you go to a sub panel, like if you have a bigger house, you might have a sub panel, or if you had a garage or something like that, your grounds and neutrals have to be separated. They cannot be together. And then that figure also just shows the different types of grounding electrodes that you can use. So you can have a ground rod, you can have a plate, you can ground to a metal water pipe, ground ring. If you're in a building or something like that, that's like I-beams and stuff like that, you can also ground that as well. Page 7 talks about the ground rod. The ground rod usually it cannot be aluminum. That's something to note. It has to be some copper or copper clad. And it has to be 8 foot minimum. So that's important. Nothing highlighted in those pages, but flipping over to page 8. Page 8, equipment grounding system, 124, third paragraph, second sentence is highlighted. Equipment grounding conductors carry fault current from the load to the grounded terminal bar of the service equipment. Key in on fault current. The equipment grounding conductors carry fault current from the load to the grounded terminal bar of the service equipment. That's my only highlights for these pages. Page 9 does show like like if you connect to a water meter or you connect a water pipe, you have to provide a bonding jumper around the water meters. That's because like if the city has to come out and change your water meter, they're not gonna unwire your stuff. You just have to bond around that water meter. Yeah. Nothing else highlighted on that page. Flipping over to page 10. Bonding, first sentence of bonding in 130 is highlighted. Equipment bonding covers the metallic, non-current carrying parts of the electrical system. Page 11, first 2 sentences are highlighted. Bonding means joining all metal parts of the wiring system, boxes, cabinets, enclosures, and conduit. It ensures having good, continuous metallic connections throughout the grounding system. After the bullet points, I've got the first sentence after those bullet points on page 11 highlighted. When the metal conduit enclosures are used, the conduit itself is the grounding means if it provides an uninterrupted path back to the service entrance. So if I want to use that conduit as my ground, it has to be uninterrupted path back to the service entrance. The immediate next sentence is a separate highlight. Circuits that have conductors enclosed in non-metallic sheets or plastic conduit must have an additional grounding wire. You got 3 questions on page 12. See if you can knock those out quick. Run through those. Number 1, grounding is the intentional connection of an electrical system to
C.
earth ground. C. 2, the 2 basic types of grounding are referred to as system grounding and
B.
equipment grounding. B. And number 3, bonding refers to what? A, the permanent joining of metallic parts to form an electrically conductive path. Section 2, electromagnetic interference. Everybody remember what that is? I gotta talk about. I mean, I feel like I talk about this all the time. So if this is a wire that has power running through it, it's got electromagnetic interference, right? That's how those. If I showed y'all a BB pin before, like where it beeps whenever you get close to a wire, that's how that works. Like if this is a BB pin, this would start beeping once it gets in the electromagnetic interference. Again, electromagnetic interference is horrible for instrumentation cable because it can induce voltages and mess up our like 4 to 20 milliamp signals for our instrumentation stuff. So it's very important that stuff is grounded and taken care of so that you don't get induced EMF or EMI in your instrumentation units. So no trade terms highlighted, but it is good to know like EMI. If I say EMI, I'm talking about electromagnetic interference. One. My first highlight on page 13, second paragraph, first sentence. Common mode noise is noise that is present between line and ground or neutral and ground, but not between each line. Common mode noise is noise that is present between the line and ground or neutral and ground, but not between each line. Next paragraph, first sentence. Normal mode noise, also called traverse mode noise, is noise that's present between the current carrying conductors or line to neutral. So you think a common mode is not noise between not hot conductors, and then normal mode is between hot and hot, or hot and neutral. Second to last paragraph on the page. Third little short sentence is highlighted. Optical fibers neither emit nor receive EMI. Everybody remember what fiber optics are made out of? Glass or the newer stuff? Might not have been this class. I don't remember if I teach this in electrical or instrumentation. The newer stuff they're coming out with is plastic. Plastic is a lot more durable than glass, but there's no like all it is a long piece of glass that they just flip their light in to send signals. So EMI has no interference on light, right? Like it's not going to interfere with a light signal. It can only be some type of electrical signal that it interferes with. Flipping the page, the first three, I don't know, the rest of that paragraph pretty much is highlighted starting on page 14. FCC regulations establish the maximum permissible emissions of electronic devices. For computing devices, the FCC separates its regulation for digital EMI into two categories. Class A is computing devices, industrial and commercial, and Class B is computing devices, residential. You're just going to, I think you'll need to know the two different classes for that one. 210, capacitive coupled noise. First sentence is highlighted. Capacitive coupling occurs when AC power lines are run parallel to signal lines. So, anybody remember what makes up a capacitor? Capacitor is two plates separated by a dielectric. So, essentially, whenever they say that power lines are run parallel to signal leads, so if I had say this was a power line and this was an instrumentation line, while they are just wires, they can still be considered plates, as small as they are. And then the insulation and the air between them can all be considered dielectric. So that you're creating a type of capacitor just by running those parallel to each other. So that's why it's called capacitive coupled noise, because essentially it's making it capacitive. Third to last sentence in that paragraph is also highlighted. Recall that this got ahead of myself. Recall that a capacitor is simply two parallel conductors or plates separated by an insulating material called a dielectric. That same paragraph, third to last sentence. Recall that a capacitor is simply two parallel conductors or plates separated by an insulating material called a dielectric. Right-hand side of the page, first full paragraph, first sentence is highlighted. Capacitive reactance is the opposition to current flow by a capacitor. Capacitive reactance is the opposition to current flow by a capacitor. Page 15. 220, inductive coupled noise. First sentence is highlighted. Inductive coupling occurs when signal lines are run parallel to AC power leads or when signal leads pass in the proximity of electric motors or generators. They're going to talk about the left-hand rule and maybe the right-hand rule. It's just I'm not going to talk about that too much because I don't feel like it's super important, but you're going to have questions on, so I have highlights. Second paragraph, second sentence. If the wires held in the left hand is shown in figure 17, such that the thumb points in the direction of electron current flow, the remaining four fingers indicate the direction of magnetic lines of force. So it shows that on the next page, so you can see the directions of the line of force. It's more like that rule is really more important whenever you're dealing with like electric motors and stuff like that. Not really relevant to the stuff we're learning. One more highlight on page 15. Last paragraph, first sentence is an online test question. An expanding and collapsing magnetic field can be used to generate electrical potentials. What's electrical potential?
Difference in voltage.
It's voltage. Electrical potential is voltage. Page 16. 230, directly coupled noise. First sentence is highlighted. The ground loop is likely the source of circuit noise that is most difficult to locate. So I've talked about whenever I'm grounding instrumentation cable, what's important about grounding the shield. I had to talk about this. Right, remember landing or grounding a shield, what's important about that, or something that you have to do? It's only on one side. You only ground this or the drain, like it's got the little shield and the drain wire, that's only on one side. If you ground it on both sides, you can create what's called a ground loop, and you can actually send current through the ground, and they are a bitch to find. Do not ground your shielding wire, your drain wire on both sides. That's what the ground loop is likely the source of circuit noise that is most difficult to locate. It's very hard, like it sends such small voltages, it's hard to trace them. The immediate next sentence is a separate highlight. Ground loops can exist wherever interconnected, non-isolated instruments are grounded at more than one location. Last paragraph on page 16, I've got the first 3 sentences, it's about half the paragraph highlighted. Another directly coupled noise source is leakage currents. Leakage currents result from poor insulation that allows current to pass from one lead to another in the form of a signal to lead or form a signal lead to ground. When there is a leakage between the source and signal leads, a noise signal is introduced into the signal circuit, similar to those introduced through capacitive or inductive coupling. Page 17, first paragraph, last sentence, long sentence. As such, the user of the instrument must be prepared to evaluate the extent of the noise, and then A, determine if the existing noise is not significant, B, eliminate the causes of unacceptable noise, or C, prevent the unacceptable noise from interfering with the instrument. Most of the time, if you get noise on a piece of instrumentation, like usually if you can't find it, it's got to be quick. Usually you're going to run like a temporary ground, like whatever the equipment is, probably something nearby, like you're going to have a piece of metal that's connected to the building or something like that. Something to where it's important. Again, it's important to have ground because it's important to have a zero. If you don't have a zero, then your voltage can fluctuate. Like it doesn't remain constant. 240, cable shielding and grounding techniques used to minimize EMI. The last sentence of the first paragraph is highlighted. One common method to combat EMI is to shield power, control, and signal cables entering and leaving assembly. That's what this blue aluminum foil stuff is. Talked about this before. This is the shielding. I'm not going to do this. Flipping the page, talking about cable shields. First sentence on page 18 is highlighted. Metal conduit is the best possible shield as it has very good shielding properties at all frequencies. So if you absolutely have to have a good shield, you might have to run a piece of conduit. I don't think it talks about it, but the other thing that reduces EMI, like you see it like these two, like this is a 4-conductor cable, twisted pairs. So this is a twisted pair cable. Twisting pairs also helps eliminate EMI. It's kind of good to know. Preventing ground loops, 242. First paragraph, last 2 sentences. Improper cable shielding practices can also induce noise problems. If too many grounds are used, a ground loop can result. in that table 1 at the bottom, you're gonna have a question on your practice test that comes from that. You just need to know, I got tensile strength highlighted. And then if you go over to the aluminum foil column, you need to know that the tensile strength of aluminum foil is 4. So that's just saying like the tensile strength of this aluminum shielding, like this is easy. There's a plastic backing on this that gives it a little bit more strength. And then y'all can look at this if you want to, but regular aluminum foil, anybody can take and just tear it apart. Tensile strength of aluminum foil is bad. Shield termination. First sentence is an online test question. Shield quality is usually compromised at the termination point. So usually whenever you're terminating this stuff, you like you can use your drain wire as a shield, but you also have to terminate this. So usually what I do whenever I'm terminating this stuff, like I twist it up as much as I can. And just like if you've ever wired a plug or anything like that, like you just have a ground terminal and you kind of just make a little hook. Well, you can imagine like that would be the best electrical connection there is. Like sometimes you might want to loop it twice, but they're just saying like that is the biggest source of where quality is compromised for terminating a shield. 244 on page 19, use of multiple shields. Second sentence is highlighted. To protect analog instrumentation against high frequency noise, a second external shield must be used. So we've talked about this before. This piece of instrumentation cabling only has an overall cable shield. There's other pieces of instrumentation where both of these pairs would also have a shield on each one of those. So this is just a little bit lesser version of trying to block out EMI. Spend a little bit more money and you can get individual pair shields. 245, signal cable types. Second paragraph, first sentence is highlighted. Aluminum foil is frequently used as the shield material on shielded cables because it is an excellent low frequency electrostatic shield. Fourth paragraph, the one that's got the voltage gradients in it, the last sentence of that paragraph is highlighted. To prevent the voltage gradient from developing, one end of the shield must be floated. So all that's saying is that means it's not connected to ground. And when you float these things, I can't remember if I've talked to you all about this. So if this is the end that I'm floating, you take your shield and your drain wire, and usually I wrap it around your cable like that. Usually I don't cut it off, but then you put, like I get some electrical tape and I tape that just in case something happens and the other end gets pulled off or something like that. And usually, like I think I've said this before, usually, so this piece of instrumentation cable usually would run from like a control room out to the equipment. Usually I'm grounding my shield in the control room because usually your control rooms are like a cleaner area. It's easier to find a ground. Out of my equipment, it might not be as easy to find a ground. But if something happened in my control cabinet and somebody cut this crazy short on accident for whatever reason, and this side was actually on my other side, I could uncoil this and find a ground or something like that to where I don't have to pull a whole new cable. But floating just means that you're coiling this thing up, putting some electrical tape on there and leaving it ungrounded. That's floating. Next paragraph, first sentence is an online test question. Coaxial cable or coax is often used to transport high frequency signals. They use coax cable is very good at not letting in electromagnetic interference. That was quick. Any questions? I know that's not the most exciting stuff in the world, but it is important. Especially whenever I'm talking about shields and stuff like that. Everybody go with that? All right, we've got practice test, section review, module review. I want that stuff done as soon as you come in on Thursday. And I'll look over it. You can take your test, and then we'll be in the lab Thursday. So after this test, we still have 2 more tests. Remember, next week, we have no classes next week. I'll be out of town all next week. But I might give y'all, I don't know that I'm gonna give y'all something to do, but, potentially like redo a chapter or something like that. Like with that? You all on Thursday. You ready for that test?